So suppose you want to measure the pressure inside a gas instead of the atmospheric pressure. So you can measure the atmosphere using a barometer, and you can measure the gas of the pressure of a gas trapped in a flask by using a manometer. So this is an open-ended manometer, so it's open on one side to the atmosphere. So you have your atmospheric pressure, so your atmospheric gas is kind of exerting a certain amount of pressure here on this column of mercury. So there's a column of mercury here. I'm going to try to color that red. So that's all mercury in there, trapped in this tube. That's all mercury. And then you have a gas over here that's in a flask. So you have gas, and those gas molecules are exerting a certain amount of pressure on this column of mercury on this side. And then you have the atmosphere, the atmospheric gases that are exerting a certain amount of pressure on this column of mercury on this side. And if the atmospheric pressure was the same as the gas pressure, these columns of mercury would be the same. So I'll draw that over here. So if they were both the same, what you would see was this level, this side, they would both be the same. And we would just say that the pressure of the atmosphere would equal the pressure of the gas. All right, so in this picture though, we have to figure out which one's pushing more, the atmospheric gases or the gases trapped in the flask. And you can tell by how low this column of mercury is. So on this side, the gas is pushing a lot more than the atmosphere because this column of mercury is all the way down here. So it's pushing a lot more, it's pushing this mercury up this way. The atmosphere is not pushing quite as much. So what you could do is you can tell tell what the pressure of the gas is by comparing it to the atmosphere. So over here in this picture on the left, the pressure of the gas, that's what we're trying to measure, is going to be the same as the pressure of the atmosphere plus whatever the difference is. So plus the pressure of the mercury, the height of the column of mercury. Sometimes that's just called H. So we'll call that H. That's just the height, the difference from here to here. So how much more is this gas pushing on this column of mercury than the atmosphere? Whatever the difference in the column of mercury, these difference in the heights of the column of mercury. Over here, here's your mercury, and this is your gas again. Now who's pushing more? The atmosphere is going to be pushing more, you see, because the side is lower. Whoa, that side's lower. Now what we have is you're always trying to measure the pressure of the gas. So here we have the pressure of the gas. It's just going to be the pressure of the atmosphere minus that pressure of the mercury, the height of the column of mercury, the difference in the columns of mercury. So whatever side is lower, if the atmosphere is lower, is pushing lower, the side of that column of mercury is lower, that means it's pushing more, which means it has a higher pressure, then the gas is going to be less than whatever the atmosphere is. Over here, the gas is pushing more. You can see because that side is lower, so it's pushing more. It's a higher pressure, so you're going to add the difference there to the pressure of the atmosphere. So let's try a real problem. So here we have the pressure of the gas, right, and we have the pressure of the atmosphere. And in the problem, they tell you what the atmospheric pressure is. They tell you the pressure of the atmosphere. So on this side is 754.2 millimeters of mercury. And they tell you that difference, right? So the difference from here to here is 30.1 millimeters of mercury. And now your job is to figure out, do I have to add that or subtract that if I'm trying to figure out the pressure of the gas? So is the pressure of the gas more or less than the atmosphere in this picture? Let's see. So who's pushing more, the gas or the atmosphere? The gas is pushing more because that column of mercury is lower than this column of mercury. So because the gas is pushing more than the atmosphere, we're going to add the H. We're going to add that difference. So we're going to have 754.2 millimeters of mercury plus 30.1 millimeters of mercury. And so when you add all that up, you end up with 784.3 millimeters of mercury. All right, there's some more homework problems that look like that. So your problem is really just to look at the columns of mercury on either side. This is the gas side, that's the atmospheric side, and figure out who's pushing more, the gas or the atmosphere. If the atmosphere is pushing more than the gas, then you subtract it. If the gas is pushing more than the atmosphere, then you add the difference in the height of those columns of mercury. One little just reminder about temperature. When we deal with this, we're gonna talk about Charles' law next. And when you're looking at temperatures and you're dealing with temperatures and gases, you want to use the temperature in Kelvin. So if you remember, temperature in Kelvin is just the Celsius temperature plus 273. Then you'll be good. So let's just do one practice exercise there. So the boiling point of bromomethane is 38 degrees Celsius. How do you figure out what the Kelvin temperature is? You're just going to add 273. So 38 plus 273 is 311 Kelvin. So we're going to do a whole lab on Charles' law. We're going to measure the temperature. Make sure you use the temperature in Kelvin. Put the temperature in Kelvin, and we'll be good to go.